Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you're all doing well. Welcome to another video from our Easy Chemistry for All channel. This is Mr. Muad, and before we start, thank you for your subscriptions guys. Thank you for helping growing the channel. If you may please, for those of you who did not subscribe yet, please subscribe, and if you can share the channel with your friends, that would be really great to help us reach our first 1000 subscriber, and also for these students to hopefully benefit from these videos. Right? Okay, so let's start guys. We are in module 16, lesson 1, state of dynamic equilibrium. حالة من الاتزان الديناميكي in Arabic, okay? But the most important word here is equilibrium, الاتزان أو الاتزان الكيميائي, okay? Which we will see while we are going. So the learning outcomes, guys, is to list the characteristics, خصائص of chemical equilibrium. نحن نذكر خصائص الاتزان الكيميائي. شو هي خصائص الاتزان الكيميائي؟ Write equilibrium expressions for systems that are at equilibrium. So we will write some mathematical expressions, okay, that shows us how the system behaves at equilibrium, and then we will use these expressions to calculate the equilibrium constant from concentration data. Okay, so we'll have some calculations. Okay, so this is part 1, this is part 2, and this is part 3 of the video. Okay, so guys, in part 1 we are going to define reversible and irreversible reactions, تفاعلات عكسية وتفاعلات غير عكسية, and we will explain chemical equilibrium and when does a reversible reaction reach it. Okay, so guys, إلى الآن, so far we have been studying irreversible reactions, one direction. Okay, إلى الآن we have been studying only irreversible reaction, اللي هي تفاعلات غير عكسية, يعني من A and B. That's it. Okay, there are other reactions where they are reversible, تفاعلات عكسية. What does that mean? It means A gives you B and B gives you A at the same time. The products can make the reactants and the reactants can make the products. These are reversible, and we will study them. Okay, alright, so these are the most important keywords: reversible reaction and chemical equilibrium. So how do you describe chemical equilibrium? That's the focus question or the main idea of the lesson. Okay guys, so when we say reversible reaction we mean تفاعل عكسي, يعني double arrow, عنده سهمين. هاي الطريقة, يعني التفاعل ممكن يروح من اليسار لليمين ومن اليمين لليسار. المتفاعلات تكون نواتج والنواتج ترد تكون المتفاعلات. Okay, that's the meaning of reversible reaction. الاتزان الكيميائي is a state of balance which we will see later. Okay, so which symbol here show a reversible reaction? Of course it is the double arrow symbol. Okay, that's the meaning of reversible. Excuse me. So chemical reactions often reach a balancing point or equilibrium. التفاعلات الكيميائية, كثير من التفاعلات الكيميائية ما تنتهي أو تخلص, لا, توصل لنقطة توازن أو equilibrium point. Okay, so let's have a look at this reaction, guys. N2 plus 3H2 gives me NH3, and the delta G is minus 33. Of course, it has a negative delta G, so it's spontaneous. The reactant concentrations decreases at first. إذا جينا نمثل هذا التفاعل, of course at the beginning we have only reactants, عندنا بس المتفاعلات. فلما يبدأ التفاعل يقل المتفاعلات لأن قاعدين نستخدمهم because we're using, and the product concentration increases. والproduct قاعد يزيد لأن إحنا قاعدين نكون فيه. Before the reactants are used up, all concentrations become constant. يعني قبل ما نخلص المتفاعلات خلاص الكميات تثبت, ما يصير في أي تغير في الكميات لا للمتفاعلات ولا للنواتج. This is illustrated in this slide, guys. have a look here. So H2 and N2 are reactants متفاعلات صح؟ And this one is products. If you see, this is the concentration and x-axis is time. At the beginning we have only reactants H2 and N2. With time we are using them, that's why they are decreasing, that's why the reactants are decreasing, and we are making the product, so it is increasing. This will keep happening until we reach this time, let's call it time x. After this time x الconcentrations كلها بتثبت خلاص. I will not get any more product and I will not lose any more reactants. Okay, so this state here we call equilibrium, نقطة اتزان. خلاص ما عاد يتغير أي شيء في التفاعل، الكميات ثبتت وما تتغير. Okay, now we will try to explain that, guys. Okay, so this reaction, guys, should be a reversible reaction. Okay, this is based on a video, but I'm not showing you the video here, but I'll show it to you later. Okay, all right, not later, I mean I'll show you the slide later, the main slide. So reversible reactions and chemical equilibrium. So a reversible reaction is a chemical reaction that can happen in both the forward direction الأمامي يعني هذا السهم إلى اليمين and the reverse reaction or direction I mean بشكل خلفي. So this is the forward reaction, N2 plus 3H2 gives me 2NH3, and this is the reverse reaction إنه النواتج تكون لي المتفاعلات. Both of them, when we combine both of them into a single equation, these two arrows are going to be these ones. And we call this a reversible reaction. يعني المتفاعلات تكون نواتج والنواتج ترد تكون المتفاعلات. Okay? So what is the difference between reversible and irreversible reactions? It's the following. In irreversible reactions في التفاعلات الغير عكسية it goes to completion. يعني we use all the reactants. يعني the reactants finish. Goes to completion in one direction. Okay? All the reactants are used up. يعني نخلص كل المتفاعلات كمية المتفاعلات. At the end only products are there. في النهاية فقط النواتج اللي تكون موجودة. الreactants المتفاعلات خلصنا. An example of that is rust. Now have a look here, guys. So this is irreversible reaction. Reactants بالأزرق والproducts بالأحمر. At the beginning we have only reactants والأحمر products zero. With time the reactants will become zero because we used all of them, and the products will increase. At the end we have only products. We don't have reactants. Okay? So it is very important for you to notice that, guys. Alright? That irreversible reactions have only products at the end والreactants تكون خلصت. Now, in irreversible reactions, that is not the case. It goes to equilibrium. يعني ما يخلص, it doesn't finish, it goes to equilibrium. يروح للاتزان. Goes in both directions, يمين ويسار. At the end, both reactants and products are there. تعال نشوف هني concentration time. لاحظ إنه الرياكتنتس بالأزرق ما استووا زيرو. So the reactants did not go to zero. يعني موجودة. Okay? And the products also increased. So in both of them, the reactants concentration at first decreased and the products increased. لكن في reversible reactions, at the end, I have both reactants and products. يعني المتفاعلات موجودة والنواتج موجودة. Okay? So this is just an example, guys. مش لازم إنه في الاتزان يكونون الاثنين متساويين. الreactants والproducts. It's not important. Sometimes they are not equal. Okay? So just for you to know. And another example for that is the following. Okay, remember this photo or this image or this graph. The concentrations of the reactants are not equal to the product. مش متساويين. But they are not zero. يعني reactants هني are not zero. That's why this reaction is reversible. يعني لما يعطيك رسمة ويقول لك هل هو reversible ولا irreversible، إذا لقينا إنه if we find that the reactants المتفاعلات become zero, it is irreversible لأن استخدمناها كلها. If the reactants المتفاعلات ما كانوا zero صاروا constant، يعني صار concentration تبعهم constant, so this is reversible reaction. Okay, all right. So we talked about this. Okay, reversible reaction is a chemical reaction that can happen in both directions, forward direction and reverse direction, guys. Okay, how does it end? Okay, does it end at أصلاً يعني? Well, it does not end. It reaches equilibrium. So now we are going to understand what's the meaning of equilibrium, guys. Okay, but before we do that, let's have a look at this graph. Okay, so have a look at this graph and then choose the correct sentence that describes this, or correct statement that describes this graph. So you have two reactants here in blue and one product in red, as you can see. The concentrations are equal beyond time 3. So this is time 3. يقول لك إن concentrations حق المتفاعلات والنواتج متساوية بعد time 3. Are these equal? No, they are not equal, guys. The concentration of reactants increase. Reactants اللي هم بالأزرق. Are their concentration increasing or decreasing? It is decreasing. So this is wrong. The concentration of the product decreases. The product بالأحمر. It is increasing. It's not decreasing. This is wrong. The concentrations are constant beyond time 3. The concentrations become constant, like they don't change after time 3. That is true. Look, they are not changing anymore. They are all going in straight line. So the correct one is going to be number C. Okay, they can give you this graph and then ask you questions like this, right? So you have to understand the graph. So how does the reversibility of the reaction affect the production of ammonia? So if we want to tell the story of this reversible reaction and how it reaches equilibrium, how can we say that? So have a look at the image. This figure shows a mixture of nitrogen and hydrogen just as the reaction begins at a definite initial rate. يعني هذا قبل بداية التفاعل أو عند البداية. عند البداية I only have H2 and N2 المتفاعلات, right? No ammonia is present at first, therefore the forward reaction will happen. The forward reaction اللي هو إلى اليمين to make ammonia. Okay? Then, as the reactants combine to form ammonia, their concentrations decrease. لأنه قاعد أستخدم أنا ال N2 وال H2 عشان أكون الأمونيا، فالأمونيا بدأت تتكون the NH3. Okay? Okay. The reaction rate depends on the reactant concentrations. يعني the speed of the forward reaction depends on the concentrations. And you remember that كل ما زاد concentration of the reactants زادت speed. But now we are using N2 and H2. احنا قاعدين نستخدم ال N2 وال H2. فالspeed of the forward reaction is decreasing. The reaction is becoming slower. Okay? As soon as ammonia is present, the reverse reaction can occur. يعني أول ما تبدأ تتكون الأمونيا التفاعل العكسي يبدأ يتكون. يعني الأمونيا ترد تكون لي ال H2 وال N2. Okay? As the reaction proceeds, the rate of the forward reaction decreases and the rate of the reverse reaction increases until the two rates are equal. يعني سرعة التفاعل الأمامي وسرعة التفاعل العكسي الأمامي تقل والخلفي يزيد until the two rates are equal. يعني سرعة التفاعل الأمامي تساوي سرعة التفاعل الخلفي. At that point, at the point where the rates are equal, ammonia is produced at the same rate or speed that it is decomposed. What does this mean? يعني الكمية اللي قاعد أكونها من الأمونيا هي نفسها الكمية اللي قاعدة تتفكك وتكون لي المتفاعلات. Okay? So the concentrations of N2, H2 and NH3 remain constant. They don't change. Because if I'm making 5 of ammonia, the same 5 are going to make these reactants. So I'm not changing the concentration of ammonia anymore. ما قاعد أغير في كمية الأمونيا أبدا. ليش؟ لأن الكمية اللي قاعد أكونها هي نفسها الكمية اللي قاعدة تتفكك وتكون لي المتفاعلات، لأن سرعة التفاعل الأمامي صارت مساوية لسرعة التفاعل العكسي. Okay? So the system has reached a state of dynamic balance or equilibrium between equilibrium هذا يكون between what? Between the forward reaction and the reverse reaction. يعني في اتزان ما بين التفاعل الأمامي والتفاعل العكسي. And that's the definition of chemical equilibrium, guys. Chemical equilibrium is a state in which the forward and the reverse reaction balance each other because they take place at equal rates or equal speeds. لأن عندهم نفس السرعات. So the rate of the forward reaction equals the rate of the reverse reaction. هاي هي خاصية الchemical equilibrium. Okay? And at equilibrium, the concentrations, all the concentrations do not change. They remain constant. Okay? Let me just show it to you here so that you can remember the graph that we saw before, guys. Yeah, this one. So if you notice, at this time here, time x, this is actually equilibrium. Why? لأن بعد هذا التايم أو عند هذا التايم ال concentrations خلاص they are not changing. ما يتغيرون. They are constant. Okay. So we can look at it. This is just another graph. صورة ثانية تشرح لنا الوضع. إنه the reactants are decreasing and the products are increasing until a point where both will stop to change. At this point, this is equilibrium. Now, this is looking at the concentrations and time. If we look at the speed, okay, of the forward reaction and the reverse reaction, the forward rate is decreasing with time and the reverse rate is increasing with time until they are both equal. So when the rates are equal, لما يكونوا سرعات التفاعل الأمامي والعكسي متساويين، كمية البرودكتس والرياكتنتس خلاص ما تتغير. Okay, again, this is another graph showing you what's happening here, the concentrations, time, and here you have constant concentrations of reactants and products, and equilibrium is reached at the same time point لأنه سرعة التفاعل الأمامي تساوي سرعة التفاعل العكسي. Okay, guys, I'll let you read this on your own, but in general, when you reach equilibrium, it's called dynamic equilibrium. ليش؟ لأن التفاعل الأمامي والعكسي لسه شغالين، لسه في حركة. That's the meaning of the word dynamic here. Okay, so dynamic equilibrium means that the total number of products and reactants is constant, but the forward and reverse reactions are still going on. Okay? Alright, that's the end of part 1. Guys, now we can go and start in part 2. Now part 2 deals with defining the equilibrium constant, K equilibrium, and writing the equilibrium expressions for systems that are at equilibrium. And we'll learn what do we mean by capital K EQ. So, the law of chemical equilibrium, اللي هي خاصية من خصائص chemical equilibrium, states that at a given temperature, يعني عند درجة حرارة معينة, a chemical system might reach a state in which a particular ratio of reactants and product concentrations has a constant value. يعني في نقطة معينة في التفاعل الكيميائي إنه نسبة المتفاعلات إلى النواتج تصير ثابتة. This is the law of chemical equilibrium. Okay? So here, if we try to talk about the law of chemical equilibrium, you will notice that هني concentration ثابت after time 3. Here it is constant. Here it is constant as well, right? So the ratio نسبة ال SO3 إلى ال SO2 إلى ال O2 ما تتغير at different times يعني. I mean after equilibrium. So after equilibrium, it does not change, or it will not change. Alright? It will stay constant. That's the main point we are making here, guys. Alright? So that's the law of chemical equilibrium. If we have a look at this equation, for example, when you see a double arrow, it's always equilibrium, guys. لما نشوف double arrow دايما في اتزان أو سهمين دايما في اتزان كيميائي. So small a, small b, small c, and small d. Okay? So if the law of chemical equilibrium is applied to this reaction, a ratio called the equilibrium constant is obtained. يعني إذا طبقنا law of chemical equilibrium, if we want to translate this law into math, إذا نريد نحول هذا الكلام إلى رياضيات, we are going to derive, or we are going to write something called equilibrium constant. Okay? What does it look like? It looks like this. The equilibrium constant expression. So K equilibrium equals the concentration of the products على concentrations of the reactants. And you will see كل concentration مرفوع إلى الباور, مثلا هاي C مرفوع على الباور small c, هاي الكوفيشنت اللي هي الرقم اللي يكون جنب المادة الكيميائية الموجودة في المعادلة. Okay? This is capital D to the power of D, meaning the number next to it here. A, small a is the number next to capital A, and small b is the number next to capital B. So A and B are the concentrations of the reactants, C and D are the concentrations of the products. Exponents اللي هي الأسس اللي هي الباورز هي coefficients in the balanced chemical equations اللي هي الأرقام اللي تكون في المعادلة الموزونة. Okay? And this is called the equilibrium constant expression, guys. So K equilibrium. So the K equilibrium is a numerical value of the ratio of the product concentrations, with each concentration raised to the power equal to its coefficient in the balanced equation. The K equilibrium is a constant value, يعني ما تتغير عند درجة حرارة معينة at a specific temperature. So if we change the temperature, the K equilibrium will change. Okay, this is very important, guys. Now, if you calculate K equilibrium and the result is more than 1, it means you have more products at equilibrium, or products are favored at equilibrium. إن كمية products أكثر في equilibrium. If the K equilibrium is less than 1, you have more reactants at equilibrium. في كميات متفاعلات أكثر في equilibrium. Okay? لأنه هاي هي البرودكتس وهاي هي الرياكتنتس. reactants تحت. The reactants are below. If the K equilibrium is more than 1, it means the products are more. If the K equilibrium is less than 1, it means the reactants are more. Okay? Now there are different types of equilibriums, guys. One of them is called homogeneous equilibrium أو اتزان متجانس. Very easy. It means all the reactants and the products are in the same physical state. يعني المتفاعلات والنواتج عندهم نفس حالة المادة. كلهم غاز، كلهم سائل، كلهم صلب، كلهم AQ. For example here, all of them are gas. So we call this homogeneous equilibrium. Okay? As you can see here, homogeneous equilibrium because all of them are gases. All the substances are gases, so it's called homogeneous equilibrium. Okay? Now, the opposite of that is heterogeneous equilibrium. اتزان غير متجانس. When does that happen? When the reactants and the products are present in more than one physical state. يعني مش كلهم عندهم نفس الحالة. في حالتين أو أكثر. Okay? Gas, solid, gas. So you have different physical states. So this is heterogeneous لأن واحدة منهم مختلفة عن الباقي. Okay? So we have gas and solid. So the physical states are heterogeneous, guys. Because we have solid here and we have gas in the other side. Now, very important rule, and we'll see it later, inshallah. We don't put liquids and solids in the K equilibrium equations. So, what does that mean? Look at this reaction, guys. If we want to write the K equilibrium, if we want to write the K equilibrium for this reaction, it will be products over reactants, right? So it will be I2 over I2. Now this is gas and this is solid. هاي gas اللي فوق وهاي solid. طبعا هني واحد وهني واحد فما نحط الباور of one here. Look at the K equilibrium that you have here. It's only the gas. We don't put solid, guys. We don't put solid في الإيكويشن. لما يكون عندي solid أو liquid هني, because this is liquid, the K equilibrium is going to be C2H5OH gas only. هاي البرودكت صح؟ على we don't put the liquids. If this was not liquid or not solid, then we will put it. Okay, guys? So we don't put liquids and solids in the K equilibrium equation. So now let's go to an example and solve. Write the equilibrium constant expression for the following reaction. So, you know K equilibrium equals أول شيء نشيك هل في solid أو liquid؟ ما في. يعني كلهم حنحطهم في المعادلة. This is the product, right? So you will do NH3. Do you see this 2? هاي 2 اللي هني to the power of 2. And then down here you will do the reactants. طبعا دايما فوق البرودكتس وتحت الرياكتنت. So this one times مضروبة في ال H2. That's it? No. We have a 3 here. So لازم تكون H2 to the power of 3. Okay, guys? So this is how we do the K equilibrium constant expressions. So this is the way the book did it. It is the same thing. All right. So now let's look at an example of another example for writing equilibrium constant. So write the equilibrium constant expression for the decomposition of the baking soda. يعني هذا التفاعل. Okay. So K equilibrium, guys, equals. Now notice that here we have solids. So I will not use these. I will not use them in the equation, guys. Okay? Or what you might do the following. You might say, okay, Na2 CO3 times CO2 times H2O. صح؟ لأن هذيل النواتج because these are the products over NaHCO3 to the power of 2 because I have 2 here. Now you know that this is solid and this is one and this one is also solid. So you need to remove them. So you will stay with K equilibrium equals CO2 concentration times H2O. And this is the K equilibrium expression. يعني من البداية ممكن على طول ما نكتبهم أو نكتبهم بعدين نحذفهم if you don't want to make mistakes. Okay? So solids and liquids السوائل والغازات we don't put it in the K equilibrium equation. Okay? And that's what you can see here. This is the book solution. All right. Ozone is created from oxygen gas according to the following reversible reaction. At equilibrium, the following concentrations exist. يعني أعطاكم أرقام. Calculate the equilibrium constant for this reaction. So they want K equilibrium. What I'm interested here is to write the equilibrium expression. أول شيء لازم نكتب معادلة ال K equilibrium. So K equilibrium equals O3 to the power of 2 لأنه في 2 over O2 to the power of 3. الاثنين gases we can put them both in the equation. So if you want to calculate KAQ, just put the numbers in the equation now. So this is the concentration of O3. So I'll put 5.78 times 10 to the power minus 30 to the power of 2 over 3.10 times 10 to the power minus 2 to the power of 3. اوكي الحين عوضنا بالكميات من اللي اعطانا. If you do that, you will find that this is your answer, guys. Okay? So you can try it. And as you can see here, this is the K equilibrium. You put the numbers and then you have your answer. Now, consider the following equilibria at temperature 300 Kelvin. Okay, you have reaction 1, reaction 2, reaction 3, and reaction 4. Which of the given reactions will contain only products at equilibrium? Okay. أي من التفاعلات هاي will contain only products. So remember, if K equilibrium is more than 1, then you have a lot of products and small amounts of reactants. Remember, we talked about this. So which one has a very, very big K equilibrium? Okay, that's the main point that you need to think about. You can see I'll just remove this for you so that you can read it. Okay, so the equilibrium favors the forward reaction to have more products, especially if the K equilibrium is more than 1. Okay, so is it reaction 4, 3, 2, or 1? طبعا it is very obvious that it will be reaction 1 because the K equilibrium is very big. It's very big. كل ما زادت قيمة ال K equilibrium كل ما كان عندي products أكثر. Okay, or favorable. The products are favorable or at equilibrium. Okay. طبعا إذا قال لي هني إذا قال لي which one will have only reactants. Only reactants. لما يقول only reactants يعني the smallest K equilibrium اللي هي this one. Okay. All right. Now we finished part 2, guys. We are going to move to the last part, and it's an application. Okay, this is an application of the K equilibrium equation. Okay, so we'll calculate it like we did here, okay. So you should remember the equilibrium constant expression, guys. We talked about it, okay. Excuse me. So we talked about the K equilibrium expression, we talked about the equation, and we said that if K equilibrium is more than one, products are favored at equilibrium. If it's less than one, reactants are favored at equilibrium, okay. And this is very important, guys. For a given reaction, for any given reaction at a given temperature, يعني fixed temperature، يعني درجة الحرارة ما تتغير، K equilibrium will always be the same regardless of the initial concentrations of the reactants and products. What does this mean? The best thing is to show you here. We have 3 experiments، 3 تجارب. هذه هي initial concentrations, guys. So when you see this small 0 here, it means initial، البداية. These are the initial concentrations, okay, for the reaction. So this is the reaction. The reaction is H2 plus I2 gives us 2HI. هذا هو التفاعل. فكل مرة ببدأ بكميات مختلفة. Each time I start with different amounts. Look here, I start with 1, 2 and 0. Here I start with 0, 0 and 5. Here I start with 1, 1 and 1. Okay? Okay guys? These are the initial concentrations. Now, بعدين لما يوصل التفاعل لحالة الاتزان, when the reaction reaches equilibrium, I calculate how much I have, and this is what I have for trial 1, this is what I have for trial 2, this is what I have for trial 3. Now these are the ones اللي فيها EQ تحت هي اللي استخدمها في معادلة الكي equilibrium لأنه هاي concentrations at equilibrium. So if you notice, if I use these values here, the K equilibrium is 49.7. If I use these values here, K equilibrium is 49.7. If I use these values here, K equilibrium is 49.7. وهذا هو الكلام اللي تكلمنا عليه. قال لك K equilibrium will always be the same regardless بغض النظر of the initial concentrations of reactants and products. يعني بغض النظر على التغييرات اللي سويتها لما بدأت بكميات مختلفة من المتفاعلات والنواتج اللي هي هني the initial concentrations. كل تجربة عندها كميات مختلفة بدأت فيها صح؟ But at the end the K equilibrium did not change at all. So this is what's mentioned here, guys. Okay? And to calculate K equilibrium, we don't use the initial concentrations, we use the concentrations at equilibrium, guys. So these are the features or characteristics of equilibrium. The reaction must take place in a closed system. So we cannot let any product or reactant leave the system or escape, because that will destroy or disturb the equilibrium. Temperature must remain constant. Okay, so closed system, temperature must remain constant, and all the reactants and products are present. يعني في النهاية في الإكوليبريم لازم يكون المتفاعلات والنواتج موجودين. And they are in dynamic motion. Remember? يعني التفاعل الأمامي يحدث، التفاعل العكسي يحدث، والكميات تكون ثابتة. Okay? So now we reach the last part. Okay guys, so this question says calculate the value of K equilibrium for the equilibrium constant expression given the concentration data on equilibrium position. So this is the concentrations, these are the concentrations at equilibrium. هاي هي التركيزات في حالة الاتزان. Okay, these are the concentrations at equilibrium. So this is very important. So we just need to use the K equilibrium and use these values. That's it. So K equilibrium equals concentrations of NH3 to the power 2. When ال NH3 هي هاي. So 0.933 to the power of 2 over concentration of N2. كم ال N2 عطانا هو 0.533 times H2 to the power of 3. What is H2? 1.6 to the power of 3. بس. And then you calculate. Okay. So when you calculate this, your answer will be 0.399. Okay. All right. So this is the answer, guys. So which is true if K equilibrium is more than 1? Remember, I told you if it's more than 1, then products are favored. Reaction is spontaneous. This is delta G negative. Reaction is exothermic. This is delta H negative. Reactants are favored. This is K equilibrium less than 1. Okay? A reaction A plus B is in equilibrium with AB. يعني A plus B في equilibrium مع sorry AB. It's gas, gas, this is gas. It says here, if the concentration of A is 3 and the concentration of B is 2 and the concentration of AB is 6, what is K equilibrium? So أول شيء من هاي المعادلة نكتب K equilibrium equals concentration of AB over A times B. وطبعا كلهم أس واحد لأنه كلهم عندهم واحد هنا. Now put the numbers, guys. Okay, so 6 concentration of AB over 3 times concentration of B is 2, so it is 6 over 6, so it is 1. So the equilibrium is 1, guys. Okay? Which of the following is true? When reactants and products are present in more than one state, the equilibrium is homogeneous. This is wrong. قلنا إذا في أكثر من state يعني gas, solid, liquid, AQ, and so on, it is heterogeneous. At equilibrium, the concentrations of reactants and products are equal. This is wrong. They are not equal. They are constant. يعني ثابتين ما يتغيرون. For a given reaction at a given temperature, K equilibrium will always be the same, regardless of the initial concentrations of the reactants and products. That is true. اللي شفناها في الجدول لو تتذكرون كنا نغير القيم ويطلع لنا ال K equilibrium 49.7. K equilibrium is constant only at a specified K equilibrium is constant only at a specified temperature. Okay, give me 1 second. So again, for a given reaction at a given temperature, K equilibrium will always be the same regardless of the initial concentrations of reactants and products. That is true. K equilibrium is constant only at a specified temperature. We did not talk about this. Okay, what we said was the following. Let me bring it back here. The temperature must remain constant. هذه من خصائص equilibrium. Okay, but what we talked about excuse me, guys. What we talked about or the main point is point number C. Okay, which is not a characteristic of all chemical reactions that reach equilibrium. Not a characteristic. Okay, يعني مش خاصية من الخصائص. temperature must remain constant هذه صح، هذه خاصية it is a characteristic, so this is the wrong answer. All reactions and products are present, that is true, so this is not the answer. All reactants and products are in constant dynamic motion, that is true, so this is not the answer. System, they must take place in an open system. We said it should be closed system, so this is the answer. And that's the end of module 16 lesson 1. Guys, thank you for watching the video. Please share and subscribe with your friends. If you have any questions, you know how to contact me. You can leave a comment in the comment section or contact me here as you see. This is Mr. Muad from Easy Chemistry for All. Thank you and wish you all the best. Take care, guys.